Hello guys, welcome to Kodamigo. In today's video, we're going to talk about linked list. In today's video, we will understand what a linked list is and why one should use them, and in our subsequent videos, we will be implementing all of its fundamental operations like inserting a node, deletion of a node, or searching of a node, and many other operations like reversing and sorting and various algorithms that we can perform on linked list. So this is the first video of this series. So in this video, we will see what a linked list actually is and what is the difference between an array and a linked list. You know that arrays and linked list both are the linear data structure. They are called linear because the way we access elements from them, we access elements in sequence. So if both arrays and linked list are linear data structure, then why one should prefer using linked list over arrays. And next we will see the types of linked list. We have time complexity of various fundamental operations that we do on linked list. Now let's understand what is a linked list in the first place. Linked list basically is a chain of nodes. So to understand a linked list, we must understand what is a node. A node in a linked list contains two things: the data that it holds and a reference to a next node. The data could be of any type, but in this example, we will make a linked list of numbers. And the second part is a next pointer that refers or points to the next node of the list. If we explicitly want to say that there is no more node after this, then the next pointer is set to null, which guarantees that the next pointer is not pointing to any valid memory address. And we also have a head reference variable that always points to or refers to the very first node or the head node of the linked list, and this head node is used in traversing the list. Now you know that linked list is a chain of nodes connected together. Now let's move on and understand the difference between arrays and linked list. When we create an array in any programming language, they require contiguous memory blocks. So for instance, if we have an array of 5 elements, and let's assume that in order to store a number, we need 4 bytes of memory, then there are going to be 4 contiguous or back-to-back memory blocks, each of 4 bytes. We will understand that in a minute with the help of animation as well. There are some benefits of using arrays. Arrays usually take less amount of time because we only store the element or the data part. We do not need to store the reference or the pointer to the next array element. The second benefit of using array is that arrays are the only data structure in computer science that provide random access. Given the array, I can randomly access any element of it. But there are some downsides also for using arrays. The arrays in most of the programming languages are of fixed size. In JavaScript, we have arrays which are dynamic arrays. In Java, there is a array list which are dynamic arrays. Linked lists are dynamic in nature. It is because of the way they are stored in the memory. Now let's understand this with some animation. We have two types of memory: stack memory and heap memory. Whenever we have to declare a variable that resides in the stack memory, so let's say ARR is a variable that's going to be in the stack. On the other hand, all the memories that we create at runtime are allocated from the heap. So let's say I have an array of 4 elements and the base address is 5600. It could be anything. I just came up with this number. So as we talked about this earlier, that array memory blocks are contiguous or back to back, meaning that the address of the next block going to be 5604 and the next block going to be 45608 and so on and so forth. So this ARR is a pointer or is referencing to the base address. Now you see that unlike arrays, the memory for node can be allocated anywhere in the heap. The next pointer of a node basically points to that memory locations. That is what makes a chain or linked list. And the last node of a list always points to a null. So now you know that the main difference between arrays and linked lists, the main difference is the way memory is allocated. Now let's talk about the types of linked list we have? Well, we have only 3 types of linked list: singly linked list, doubly linked list, and circular linked list. In singly linked list, there are going to be only one pointer part or only one reference that will point to the next node, and the last node will point to null, and there would be a head, so-called reference variable, that will always refer to the first node. That makes a very simple linked list. But in case of doubly linked list, there are 2 pointers or 2 references. They are called next pointers and preview or previous pointers. So on doubly linked list, it is possible to go in both directions, and hence they are called as bidirectional linked list as well. Circular linked lists are nothing but a variation of singly linked list or doubly linked list, in which the last node points to the head or the first node, and that makes a loop or a circle. Hence they are called circular linked list. Time complexity of inserting a node is bigger of n in linked list because we have to traverse all the node of a linked list. On the other hand, we know the length of the arrays, and we simply can add one item at the end of arrays, so it takes bigger of 1. In case of searching, time complexity in linked list as well as in arrays is same, which is bigger of 1, because in order to be able to find an element, we have to traverse both linked list as well as arrays. The deletion is also much fast in arrays. We have to shrink the size of the array's length by 1, and the last element will be deleted. But in case of the linked list, we have only one reference variable, which is the head. So in order to get to the last node, we have to traverse all the nodes of the list.